Good morning, this is Jennifer Martinez, and in this video we're going to talk about something new. We're going to talk about a concept called rate of change, which is section 1.4 on page 22 of your class notes booklet. And the title of section is called Functions and Change. So let's start with example 1. The table below here shows your distance, so y is your distance, and you notice here it says miles, from home on a road trip, where t is the number of hours after noon, after 12 noon. So when t is 0 here, it's 12 noon, so at 12 noon you went 100 miles from home, and 2 hours later, which is at 2 p.m., you're 220 miles from home, and so forth. The question asks you to find your average rate. This is going to be your rate of change. We'll see that in a minute. Your average rate, your distance from home, is changing, so that's why it's called rate of change, over each 2-hour interval. So if you remember, we talked about this before, distance equals your rate times your time. So distance is rate times time. So here's the rate right here. So I'm going to divide both sides by t, and I'm going to put the r on the left side. We know it's the distance over the time. So the first one, or I should say the first interval, because it's asked you to do it for each 2-hour interval, we're going to be looking at these two numbers. So what is our distance? Well, you can't just say 100 over 0 or 220 over 2, because that's the total distance. We need to find the distance we traveled in those 2 hours, because the time is going to be 2. So you're going to have to subtract. This is going to be 220 minus 100 over 2 minus 0. So the distance we traveled in the first 2 hours is 120. Divide that by 2, and it looks like 60. So, by the way, the distance is in miles. And the time, this one is in miles. The time is in hours. So what we say is this is miles per hour. We saw this before. We're going to call it MPH for miles per hour. That is the rate. The reason it's a rate of change, because you can see we're changing, and the miles per hour makes it a rate. Let's do the second two and see what we get. So I added this t. This means t is between 0 and 2. T is less or equal to 2, but bigger or equal to 0. We'll see this in the future. You don't have to write this if you don't want to, but let's look at the second interval. So let me erase this and now look at from 2 to 4 and see what we get. So what is the rate? We're going to do the same thing. We're going to subtract 320 minus 220 over 4 minus 2. So that's going to be 100. That's going to be a different. We slow down the second 2 hours for some reason, because now we're only going 50 miles per hour. The same thing. This is a miles. That's an hour, so it's miles per hour. We're slowing down. The rate is not constant. We're going to see in the chapter 2, when the rate is constant, your function is going to be linear. But in this section, we're just going over what is the rate of change. Okay, finally, let's do the last interval. What happens when t is between 4 and 6? So again, I'll erase this and then look at the 4 and 6. What's happening there? Because we're going down again, so you still have to say new minus old. And then this would be 6 minus 4, right? The total hours is 2. And then we went 300 miles from home, and then we went back to 200 miles from home. What happened? Oh, we must have turned around. So if we look at the numerator here, notice that that is a negative 120 over 2, which is a negative 60. So what does a negative mean? Oh, it must mean that we're going back home. So we're going to see in the future when the rate of change is positive, you're going to be increasing, and the rate of change is negative, you're going to be decreasing. Again, it's increasing since the rate is positive here. This one is, these two actually are. And it's negative, decreasing since the rate is negative. So here is the formula in math terms. It says, and then we'll try this one, a formula for the average rate of change. If y equals f of x is a function, we had that, changing from x equals a to x equals b, then the change of the x we saw up there was b minus a. We call it delta. This delta right there means change. So that's what they like to, in math it means change, and so they'll add a delta x there. Change in output, the change of output would be the new minus the old, right? So if you look at this one right here, let's just do this one real quick here. For this one, it looks like the f of 2 minus the f of 0, doesn't it? If anyone don't know what those numbers are, it would be f of 2 minus f of 0 would be the numerator, would be the change of y. So that's what I'm going to do here. F of the new minus f of the old. In other books, sometimes you might have seen y sub 2 minus y sub 1, right? Because we don't know what those y's are. Sometimes you see this as x sub 2 minus x sub 1. Some of you might have seen it like that. But in this book, we like to use function notation. Function notation sometimes is taught in intermediate algebra. And so beginning algebra, they don't use this notation. So we're going to just start with the function notation in this class. So the average rate of change is going to be of y between x equals a and x equals b is given by this numerator, which is the f of b minus the f of a, all over the delta x, which we saw was b minus a. And that is it. If you remember, there's a slope formula. We're going to see that this is the slope when it's linear. So not yet, not in this section, it's just the rate of change. But you might have seen it as y2 minus y1 over x2 minus x1. And that represents the rate of change as well. And it's called the slope when your function is linear, when the rate of change is always constant. And we'll talk about that in chapter 2. Let's find the average rate of change of f of x equals x squared between x equals 1 and x equals 3. So let's do that. So I started by writing the formula for the average rate of change. And we know that the b is 3. We'll call a is 1 and b is 3. So I'm going to say this is f of 3 minus f of 1 all over 3 minus 1. So this would be f of 3. Oh, we plug in a 3 for that, so that would be 3 squared, which is 9, minus 1 squared, which might as well just do that now. 9 minus 1. Yep. And then 3 minus 2, we know is 2. So the answer is 8 over 2, which is 4. And I don't know the units because they didn't give me the units, so I'm just going to say 4. This is going to not be linear. If you tried from 3 to 4, you're going to see that you would get a different answer. So it's because this is a curve. If you put this on your calculator, you go to, I have the steps right here, y equals. If you remember, you have to type in the the xt theta, and then the squared button, and then zoom on the top line, and then finally go to standard. Standard is number 6. You can press 6, or you can scroll down and press enter. So you can see it's a curve. So it's going to turn out that the rate of change on curves is going to be different from each interval, just like the one that we did above. If you graph those points, it would probably be a curve. When it's a line, we're going to see this in chapter 2, it will be linear. It'll be the same for every value. They won't be different. So let's go ahead and try the next page, because we'll learn that later. So this is trying to give you the idea of this new notation and all the different quantities and what they mean, ending with the rate of change over here. So a car has traveled f of t miles, so capital F of t is in miles, t hours after it starts a journey. Interpret each equation in terms of the car in units. So the first one just means 5 hours, and 5 hours later he traveled 300 miles. Since this is the t, so the 5 is the hours, and then the whole thing is the f of t, which is in miles. Similarly, what does f of 6.3 equal 339? Again, the 6.3 is the hours. So in 6.3 hours, the car traveled 339 miles. Part C is the actual change, what the car did in 5 hours to 6.3 hours, the subtraction of that. So from 5 hours to 6.3 hours, he traveled, if you subtract these, 39 miles. Or you could say that the car traveled 39 miles from the 5 hour mark to the 6.3 hour mark. It's the change that he traveled. Now we want the rate of change. So this is what the rate of change is. So the rate of change from over that interval is 30. Because we have here, if you subtract the 6.3 minus the 5, you get the 1.3. And then, so this is exactly our formula. As you can see, where the B is 6.3 and the A is 5. And again, if you subtract those, you do get 1.3. So you could say that the average rate of change of the car is 30 miles per hour over the interval from the 5 hour mark to the 6 hour mark. So now you're going to try exercise 1. There's 3 parts here. You can try all 3 parts and come back for the solution. Here's the solution to the first one. So I'm just going to write down my formula. The B is 6 and the 3 is A. Plugging in f of 6, that's 6 squared minus 3 squared. So we have 27 over 3, which is 9. If you remember, on our last page, we did this exact same function from, what did we do? 1 to 3. From 1 to 3. Now we're doing 3 to 6, and you can see there are 2 different answers if you look back on the page before. The one on the previous video on the page before was 4. Now we're at 9. If you got this right, great, continue on. If not, pause it and try the next 2 to see if you can get those right. Here's the next one. This one's a little long, so I decided I would just give the solution to this one before I did C and D. So f of 4 minus f of negative 1. So just be careful of that negative 1, because 4 minus a negative 1 is actually 5. And in the numerator, you can use your calculator here. But this whole answer, if you plug in 4 cubed minus 8 and then plus 1, it should be 57. And then this one, this is negative 1 and plus 1 cancels, so you just have a minus 2. So it turns out to be 11. So now the answers to C and D. You'll notice that C and D are both 10 because this turns out to be linear. If you graph this, again, I just go y equals and type this in. Then zoom 6 or standard, you'll see it's a line, which is linear.